Prometheus, a 2012 science fiction film directed by Ridley Scott, follows the journey of the crew aboard the spacecraft Prometheus. They discover a star map among ancient Earth artifacts, leading them to explore the origins of humanity. This video explores a significant surge in intelligence over the last 10,000 years. It poses the intriguing question: is this rapid development a product of natural evolution or perhaps influenced by genetic engineering?
A king has his reign. And then he dies. It's inevitable.
Prometheus has landed.
These are ancient civilizations that were separated by centuries, and yet this same pictogram was discovered in every one of them.
They're smiling.
I think they want us to come and find them.
We're all here because of a map you two kids found in a cave.
Not a map. An invitation.
From whom?
Please tell me you can read that.
Prometheus, are you seeing this?
Whatever that probe is picking up, it's reading life form.
What do you mean a life form?
Oh, the head. They're changing. Changing into what?
It's moving? These things moving?
What is that?
There's a ship. They're leaving.
To go where?
Earth.
It was so wrong. Take us home! If you don't stop it, there won't be any home to go back to.
Where's that door open? Cut it off! Cut it
Big things have small beginnings.
This film raises questions about evolutionary theory, challenging the notion that humanity merely evolved from ancient Homo sapiens through gradual changes driven by natural selection and climate influences. Some argue that after millions of years of primitive existence, as hunter-gatherers, Homo sapiens underwent a rapid transformation within the last 10,000 years, evolving into the most intelligent beings in the universe, like us. Check out this video on Human Origins 101 by National Geographic.
Millions of years before industry, agriculture, and civilization, the world stage was set for one creature's unprecedented rise. The story of humanity's evolution began about 7 million years ago, when the human lineage broke away from that of chimpanzees. Over time, an ensemble cast of over 20 early human species, or hominins, came to the fore. Most became extinct, while others might have been ancestors to today's humans. Each species exhibited varying degrees of human-like physical and behavioral traits, such as large brains, small teeth, bipedality, and tool use. These hominins fell into three major groups: early hominins, Australopithecines, and Homo genus. Humanity's earliest relatives lived between 7 and 4.4 million years ago in Africa. Having most recently shared a common ancestor with chimpanzees, they had many ape-like traits, such as a small cranial capacity. However, fossils show that some ancient hominins were also beginning to show human-like characteristics, such as small canines that were likely used more for eating and not for hunting or fighting. The next phase of hominin evolution involved primates called Australopithecines. They lived between 4.4 and 1.4 million years ago across the African continent. Like their ancient brethren, Australopithecines had some ape-like traits. However, changes in the skull, spine, and legs indicate a notable shift toward a very human-like trait, consistent bipedal locomotion. The third and current phase of human evolution involves members of the genus Homo. The earliest Homo species likely date to more than 2 million years ago, making them a contemporary of some Australopithecines. But unlike earlier hominins, who exhibited a mosaic of ape and human-like traits, Homo species were becoming distinctly more human. Their cranial capacity was growing larger than any other hominins. They developed sophisticated stone tool technology, and they became the first to control fire. These physical and behavioral adaptations, along with advancements in technology, allowed some Homo species to be the first to migrate out of Africa and explore the rest of the world. While a cast of over 20 hominin species have walked this earth, only one remains. Homo sapiens, shaped by millions of years of evolution, embarked on a journey of exploration and industry its ancestors could have only dreamed.
According to the video, after millions of years, human species lived as hunter-gatherers and suddenly became remarkably intelligent within just 10,000 years. Really? Now consider reading this book, The Adam Paradox Hypothesis, unraveling the mysteries of evolution and intelligence. Intelligent individuals may seek insights from the Prometheus sci-fi film to challenge the outdated notions of traditional evolution theory, which heavily relies on climate change as a driving force. The book, The Adam Paradox Hypothesis, presents an improved perspective on human origins. It aligns with the Quran, which asserted 1400 years ago that God created Adam from DNA extracted from Homo sapiens existing 300,000 years ago, referred to as Y chromosomal Adam. This narrative suggests divine genetic engineering played a role in the creation of the most intelligent beings on Earth. So let's delve into what the book has to offer. The undeniable truth is that our DNA originates from the DNA of our forebears who were shared ancestors with chimpanzees. The investigation of endogenous retroviruses, ARVs, has uncovered 205 shared insertions in human and chimpanzee genomes indicating a common ancestral origin. These ARVs, remnants of ancient viral infections, integrate into germ cells and occasionally become inherited across generations. Among these insertions, 6 are unique to humans and 3 to chimpanzees, suggesting subsequent divergence or deletion mutations. These findings support evolutionary theory reflecting shared lineage between the two species. ARVs serve as stable genetic markers indicating genetic continuity predating the human-chimpanzee divergence. Furthermore, ERVs shed light on ancient viral encounters shaping genetic landscapes with consistent patterns across species, supporting the hypothesis of shared evolutionary ancestry. Let's observe how endogenous retroviruses demonstrate the shared ancestral lineage between us and chimpanzees. This video is sourced from a YouTube link accessible on the internet.
Endogenous retroviruses. You've probably heard that great apes like chimpanzees are humankind's closest living relatives. Even before evolution was discovered, scientists studying comparative anatomy already grouped humans into the ape family alongside chimpanzees. In those pre-evolution years, however, The word family was often used figuratively. Many scientists held a fixed species view. They thought humans and chimpanzees had been similar yet different since the dawn of time. This changed by the end of the 1800s. Along with the discovery of the process of evolution, the study of fossils convinced the majority of scientists that humans and chimps do share a common ancestor. We really are family. Today, hundreds of transitional fossils have been found, representing over 20 distinct groups which blur the line between humans and chimpanzees. That said, some people feel that the study of fossils is too subjective. It's known that DNA is great at revealing family relationships. In the court of law, DNA evidence is the gold standard for determining who the father is. DNA evidence is now widely used in the study of genealogy to figure out more distant family relationships. And there are many independent ways that DNA evidence can be used to reveal family relationships even between different species. Here, we'll zoom in on just one line of DNA evidence: endogenous retrovirus DNA shared across species. In this case, between humans and chimpanzees. To understand why retrovirus DNA is such a big deal, let's first take a quick look at what retroviruses are. A retrovirus is a special type of virus that reproduces by inserting its genes directly into a cell's DNA. The virus genes become a seamless, permanent part of the host cell's genome. The cell treats the virus DNA as if it were its own. It reads the virus genes, using them to make new viruses, and when the cell copies its own DNA before reproducing, it also copies the virus DNA and passes it on as well. In mammals, modern retroviruses usually infect white blood cells. If, however, a retrovirus happens to infect a sperm cell or egg cell, and if that sperm or egg cell ends up participating in fertilization, the resulting child will have a copy of virus DNA in every single one of her cells. She'll even pass it on to her kids if she has children. When a retrovirus becomes a permanent part of a species' DNA, whether or not it's functional, scientists call it an endogenous retrovirus. Endogenous because it is inside us from birth. It turns out that the human genome contains thousands of endogenous retrovirus segments, long stretches of DNA with sequences that match those of retroviruses. Luckily for us, none of ours can still make full-fledged viruses. They have simply mutated too much to perform their original virusy functions. Okay, so if all of this is news to you, it's probably a lot to take in, so let's recap super quick before we look at how endogenous retroviruses act as evidence for evolution. An endogenous retrovirus is a stretch of DNA found in your DNA that got there when one of your ancestors was infected by a retrovirus. On rare occasions, virus genes find their way into sperm and egg cells where they can go on to become a permanent part of a species' genome. Your endogenous retroviruses act as historical records of past infections suffered by your ancestors. Now, at this point, you might be asking, how do we know for sure that genes with similar sequences to virus genes actually came from viruses? Has this been experimentally demonstrated? In several different cases, yes. Scientists recently took human cells incubated in petri dishes and slightly mutated the DNA of one of our endogenous retroviruses to see if it would start producing viruses again. Sure enough, it worked. An extinct virus was revived from a DNA sequence found in our very own human genome. Endogenous retroviruses really are the remaining scars of ancient virus infections. So, how does this all act as evidence that humans, chimps, and other primates really evolved from a common ancestor? In 2003, the first draft of the chimp genome was published. Overall, chimp DNA and human DNA sequences are incredibly similar, but unless we dive deeper, this fact alone can't tell us for sure if evolution is a better explanation than the fixed species idea. We already know that humans and chimps have similar traits. If DNA codes for traits, we should expect our DNA to be similar as well, right? In many cases, this is a reasonable point, but not in the case of endogenous retroviruses. Remember, your endogenous retroviruses show you the unique history of specific virus infections suffered by your ancestors. They're like scars in our DNA that an individual acquires during its lifetime and can pass on to his or her descendants, but only his or her descendants. Here we're looking at maps of human and chimp chromosomes side by side. chromosomes are the structures in our cells that contain our DNA. If humans and chimps share a common ancestor, and if at least some of the infections we find in our genome occurred before the chimp-human split, we should find the same virus genes in the exact same locations in both human and chimp genomes. In contrast, if humans and chimps are not related, they should not share the same history of virus infections. Now, of course, it is possible that throughout history, both species, humans and chimps, were infected by some of the same viruses. Humans and chimps sometimes get each other sick today. But if chimps and humans are not related, those virus genes will not be found in identical locations of both chimp and human DNA. This is because when a retrovirus infects a host, there are many different spots in the host's genome where it might end up inserting itself. Extensive lab experiments with retroviruses have found that there are far more than 10 million possible insertion spots in the human genome. In other words, the chance of a human and a chimp getting infected in the exact same spot by the same specific type of virus is far less than 1 in 10 million.
So you're telling me there's a chance?
Well, it's ridiculously unlikely and it gets worse fast. If two individuals are both infected with just 12 of the same viruses, the chance that each of those 12 inserted themselves into the exact same DNA locations in both hosts is less than 1 in the number of all the atoms estimated to exist in the entire observable universe. To get a rough idea of how many insertions are shared between humans and chimps, researchers scanned both of our genomes looking for a type of retrovirus they knew was common in humans. They found 211 insertions in the human genome and 208 in chimpanzees. To figure out if any of these insertions are in the same locations in both humans and chimps, they compared the unique flanking DNA sequences on either side of each insertion. If you think of the virus as a scar, the flanking sequences are the healthy bits of tissue around the scar that tell you where the scar is located. They found that we share not just 1, not just 12, but 205 insertions. 205 out of 214 for this particular virus group. This makes perfect sense if we consider the evolutionary view of life. The 205 shared viruses were inserted sometime before the chimp-human split. The 6 insertions unique to humans and the 3 unique to chimps either represent insertions that happened after the split, or they represent deletion mutations that removed a few viruses in just one lineage after the chimp-human split. In contrast, if we want to believe the fixed species view, we're forced to conclude that these viruses are simply shared by coincidence. When we do the math, even making sure to account for the 9 viruses not shared by the 2 species, the chance of this happening by coincidence is less than 1 in this crazy number right here. This evidence should be enough for even the most reluctant yet rational person to carefully set aside the fixed species view. Endogenous retrovirus DNA alone is more than enough to independently confirm what we already knew from the study of fossils. That said, what we've seen here is just the tip of the iceberg. There are many other lines of DNA evidence available. Together they demonstrate beyond all reasonable doubt that humans and chimpanzees did evolve from a common ancestor.
Return to the book. The concept of Adam being the origin of modern humanity is derived from a Quranic verse, chapter 4, verse 1. This concept elucidates that humanity originated from a single soul, Adam, created by God from clay, symbolizing the essence of DNA. Before we proceed, let's first listen to the original verse recited beautifully in Arabic by Sheikh Khalid Al-Khani. Quran chapter 4, the women, verse 1. O humankind, be conscious of your Lord who created you from one soul and created its mate from it and propagated from the too many men and women.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم
يا أيها الناس اتقوا ربكم الذي خلقكم من نفس
This book refers to the Quran as a source of information beyond our earthly realm. So allow me to introduce the Quran to you. The credibility of the Quran as a reliable source of scientific information is supported by several factors. Its linguistic precision is evident in chapters where precise word counts align seamlessly with the narrative reflecting scientific accuracies that affirm its divine origin. Additionally, the Quran's alignment with scientific knowledge predates modern discoveries, demonstrated through its descriptions of cosmic events and human embryonic development. The emphasis on practices like prayer, fasting and charitable giving in the Quran resonates with scientific findings on their health benefits. Mathematical patterns such as the golden ratio further attest to its divine origin, alongside its meticulous preservation as evidence of its authenticity. Overall, the Quran's multifaceted evidence solidifies its reliability, validity, and completeness as a scientific source, marking it as a pristine and meticulously preserved sacred scripture. Now, let me play the recitation of chapter 1 of the Quran, which consists of 7 verses. These verses are recited daily by billions of people, a minimum of 17 times during their 5 daily prayers.
بسم الله الرحمن الرحيم.
In the name of Allah, the entirely merciful, the especially merciful.
الحمد لله رب العالمين.
All praise is due to Allah, Lord of the worlds.
الرحمن الرحيم.
The entirely merciful, the especially merciful.
مالك يوم الدين.
Sovereign of the day of recompense.
إياك نعبد وإياك نستعين.
It is you we worship, and you we ask for help.
اهدنا الصراط المستقيم.
Guide us to the straight path.
صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين.
The path of those upon whom you have bestowed favor, not of those who have evoked your anger or of those who are astray.
Let's come back to the book. From the video presentation by National Geographic on human origins, it's evident that Homo sapiens represents the apex of evolutionary progress. However, despite millions of years passing, the population remains relatively small, standing at just 1 million. While adept at hunting and gathering, with survival instincts honed over millennia, there's evidence of limited progress. Let's contrast the gradual advancement of intelligence in Homo sapiens over millions of years of evolution with the concept of divine genetic engineering during the creation of Adam. This juxtaposition emphasizes the impressive progress seen in Adam's descendants during the post-Neolithic revolution. Within this relatively short span, the global population has surged to 7.8 billion. Approximately 10,000 years ago, akin to the final moments of a 24-hour period, humanity experienced a substantial leap in intelligence, cognition, consciousness, and spiritual awareness. To me, the concept of our creation involving divine genetic engineering appears more reasonable than solely attributing our exceptional intelligence to climate change. This viewpoint is reinforced by the fact that the Quran, as a reference, is a preserved text, a book that is complete, precise, and trustworthy, and is memorized by millions. So instead of following the lead from Star Map among ancient Earth artifacts, we refer to the Quran to lead to explore the origins of humanity. What is genetic engineering and its potential applications? Let's view the video.
Genetic engineering holds great promise for the future of humanity. A growing number of scientists believe that we will soon be able to engineer and change our genes in a way that will help us live longer and healthier lives. David Sinclair is a geneticist at Harvard Medical School. He believes it's possible to unlock the fountain of youth, but how much should we really tinker with our own nature?
Nothing about our lives is natural. Maybe the oxygen we're breathing is natural, but everything else is unnatural. It's human-made, it's man-made, and we change our environment. And tackling diseases and tackling aging is also natural. That's what we do as humans. We don't accept misery and frailty as natural ways of life. We should not be doing that for any disease, and we should not be doing it for old age either.
Since before the first Homo sapiens walked the earth 200,000 years ago, we've been shaped by our own inventions. We evolved from tribes of foragers and scavengers to hunters and gatherers, agriculturalists, industrialists, and eventually modern-day digital technologists. All these advancements have had profound effect on our species, but we haven't stopped there. Biotechnology is bringing about another age of humanity.
Well, there are two types of information in our bodies that are essential for life. One is genetic, and the other is epigenetic. Epigenetic is the term for any process and structure that governs the way the genetic information is packaged and read by the cell. All of our cells, essentially all of our cells, have the same genome, but what distinguishes a brain cell from a liver cell, and what allows a fertilized egg to become a 26 billion composite of different cell types when it's born, is the epigenome. And the epigenome, I believe, is the reason that we age. A nerve cell in an older person is no longer fully a nerve cell. It's starting to move around in so-called Waddington landscape space or epigenomic space, and it's becoming a different type of cell. A nerve cell in an old person may be partly a skin cell. I mean, think about that. No wonder we start to lose the function of our retina. No wonder we start to forget things if our cells don't maintain their epigenomic information. Question is, though, can we slow this down? And can we reset the system? Is there a reboot? Is there a backup hard drive of this early setup that we can access and restore that structure? I believe that it's possible.
Considering our remarkable prowess in genetic engineering, could it be imagined that approximately 10,000 years ago, God, the creator of the universe, crafted Adam, the first human, through divine genetic engineering, endowing him with exceptional intelligence? The decision now rests with you. Employ your common sense, logic, and open-mindedness in your deliberation. Strive for fairness and honesty in your assessment. Might I extend the invitation to explore the website located at www.yulianroess7.com. Should you seek deeper insights, consider immersing yourself in the pages of the Adam Paradox hypothesis. May your reading journey be enriching. Gratitude for your attention. Yulian Roess.
Thank you.